Hello everyone. So we will continue the discussion of Group B of St. Lawrence College Center of Examination. So we will begin here from question number 5 because we already have completed the discussion up to question number 4 in previous discussion. Okay, so let us look at some information in this question number 5, and we will be looking the questions given to us. So a solenoid is connected in series with a battery and a switch as in figure given. A small coil connected to a sensitive emitter and placed near to the end of the solenoid. As the current in the solenoid is switched on, there is a current induced in the small coil. This induced current give rise into a magnetic field in the small coil. Okay, so this question is particularly related to Lenz's law. Similarly, development of magnetic field due to current, that is magnetic effect of current, and Faraday's law. Okay, so we have to utilize all these three laws together here. So सुरुमा हेरौं, यहाँबाट करेन्ट पठायो भने यो सानो सोलेनोइडमा करेन्ट पठायो भने obviously यो सोलेनोइडको एक्सिसमा म्याग्नेटिक फिल्ड हुन्छ. अब त्यसको लागि लेट मी जस्ट ड्र अ स्मल डायग्राम. सो मानौ यो करेन्टको डाइरेक्सन हो सोलेनोइडमा. राइट एन्ड स्क्रू रुल युज गरौँ. राइट एन्ड स्क्रू रुल or राइट एन्ड थम्ब रुल युज गर्ने हो भने if we grab the turns of the coil, turns of this solenoid in the direction of curling of finger, then the thumb gives the direction of magnetic field. So it is going to be your N pole and this is going to be your S pole. Obviously, यसको माथिपट्टि अब के छ? Small coil छ. Okay, this is let's say small coil. This is solenoid and this one is small coil. Okay, initially switch off भएको बेला यहाँनेरि current flow नगरेको बेला यहाँ flux 0 थियो. As soon as you will turn on switch, the flux will be generated by this one. So यसले produce गरेको यो मानौ यो flux हरु यसरी यहाँबाट क्रस गरेर जान्छ. Okay, this is the magnetic flux. यो solenoid बाट निक्लेको magnetic flux हो. So यहाँबाट पास गरेर जान्छ. अनि small coil मा अब के हुन्छ? There will be the change in flux. Because of change in flux in a small coil, the induced EMF will be developed. अब induced EMF को direction चाहिँ कता हुन्छ त? We have to apply Lenz's law. Lenz's law अनुसार हेर्ने हो भने जहिले पनि सिस्टममा केही चेन्ज आयो भने त्यो चेन्जलाई रिपेल गर्ने गरी, त्यो चेन्जलाई रोक्ने गरी करेन्टको डाइरेक्सन सेटअप हुन्छ. अब यो एन पोल यतातिर डेभलप भएको छ भने यसलाई रिपेल गर्नको लागि, यसको इफेक्टलाई न्यूट्रलाइज गर्न अब यहाँनेरि पनि एन पोल हुने गरी नै यसले ईएमएफ सेटअप गर्छ र करेन्टको डाइरेक्सन त्यसरी नै हुन्छ. अब फेरि हामी के गर्छौं? अगेन वी विल युटिलाइज द सेम रुल, राइट ह्यान्ड थम्ब रुल. राइट ह्यान्ड थम्ब रुल अनुसार म्याग्नेटिक फिल्डको डाइरेक्सन यतापट्टि हुनुपर्छ, डाउनवर्ड हुनुपर्छ भने द current should move in the direction of what? Clockwise direction. So this is what the direction of current. So if you have connected sensitive emitter here, and if you just name them, this side is X and this side is Y, the current will flow from X to Y. Okay, so this is the idea, and I believe there are some questions related to this one. So I'm gonna talk the discussion for this question number A, B, and C. Okay, so let us look at the questions. Okay, so draw an arrow on the axis of the solenoid to show the direction of magnetic field. So this is the answer. This particularly is the answer of A. This is of A. Explain the direction of magnetic field due to induced current in a small coil. So this you have to explain in answer of B. Okay, so A number को answer हामी यति बनाउँछौं भने B number को यो बनाउँछौं र मैले अघि डिस्कस गरेकै कुरा है, अघि डिस्कस गरेको कुरालाई एक्सप्लेन गर्नुपर्छ because it is for 2 marks. The direction of magnetic field will be down to up, and then the induced EMF should be produced in such a way that the magnetic field will be closer to the end pole of the solenoid. Okay, so you have to explain that for question number B. And let us see question number C. C number ma ke information deko cha tyo rakhau. So area of the cross section of the coil is 1.0 into 10 to power minus 4 meter square. Number of turns is n equals to 75 turns. Okay, the current in a uniform magnetic field produced, that is of 1.4 into 10 to power minus 3 Tesla. There is milli Tesla in here, and the direction, okay, of the current is switched reverse in 0.12 second. Okay, let's say the time change is 0.12 second. We have to calculate the average induced EMF in coil. Okay, this is so simple. From Faraday's law of electromagnetic induction, N d phi by dt. So if we are just talking about magnitude, then we can write this much direction लेख्ने भने minus पनि लेख्न सकिन्छ. हामीलाई यहाँ डाइरेक्सन चाहिएको छैन, हामी magnitude मात्रै निकाल्छौं. d phi भनेको NAB cos theta. Cos theta को value यहाँ parallel लिन्छौं, direction of area vector and the direction of magnetic field. So this is gonna be dt. So this gives us the value of EMF. This comes in certain volt. This is the solution for question number 5. Okay, so now let us move on to question number 6. Okay, so question number 6 ma ke information cha herau ani त्यसपछि यसको solution हरु गरौं. In Thomson setup, for the determination of E by M, accelerated electrons enter the region of cross field. Okay, ठीक छ. What do you mean by cross field? Cross field is that field, okay, cross field is that field in which the electric and magnetic field are normal to each other and capable of producing equal displacement of the charged particle in opposite direction. That is what we call the cross field. For example, let's say this is the region of uniform magnetic field, and if you pass some charged particle like an electron, and if you have just kept plus a terminal here and minus terminal here, and if you pass this electron from here with certain velocity, then this magnetic field likely to draw down in downward direction. In the meantime, this magnetic field, electric field likely to bring it up, so that the net effect is going to be 0. So this kind of field is called cross field. Okay, so हामीलाई यहीबाट calculate गर्नु छ है. अब B number मा चाहिँ how E by M is determined. So simple. So अब यही diagram लाई use गर्छु. Definition लेखेँ. B number को यही हो solution. मलाई थाहा छ यदि यो इलेक्ट्रिक फिल्ड म्याग्नेटिक फिल्डले जति यो यसलाई फोर्स दिएको छ त्यति नै फोर्स इलेक्ट्रिक फिल्ड लाउने हो भने the electron will reach this location. So when both field are on, in presence of electric field, force on electron is how much? Force on electron is F electric field equals to E. So this is electric field. So E is capital electric field. Okay, this is in upward direction from minus to plus, and magnetic field is in the direction inward. Okay, this is cross one. Okay, so this is what electric field. And in magnetic field, force on particle, force on electron here, electron is FB. So this is BQV. We know these two fields are equal. They are going to produce same amount of force in equal and opposite direction. यो magnetic field यतातिर draw गराउन खोज्छ भने electric field ले यही charge particle लाई माथितिर. Okay, actually यो बाहिर भन्दा पनि, so it would be better to draw inside. Magnetic field भन्दा बाहिर त हुँदैन यो charge particle को displacement. त्यसैले let me draw properly. Okay, so यो charge particle यसरी displace हुन खोज्यो भने यो electric field ले यसलाई के गर्छ, यतातिर यो FB भयो भने अब यतातिर यही charge particle लाई माथितिर एउटा फोर्स लागेको हुन्छ ओके यो फोर्स भनेको FE हो यो दुईटा इक्वल एन्ड अपोजिट भयो भने दिस इज द लोकेसन अफ चार्ज पार्टिकल ओके सो देयरफोर यो दुईटै बराबर हुन्छन् FE equals to FB so what I can write is EE equals to how much B in place of Q I should write electron so EV therefore यो E काटिन्छ र velocity को value हुन्छ E by B okay once you get the velocity of electron in here you can simply follow the idea of kinetic energy of the particle okay so again for kinetic energy of the particle this kinetic energy of the particle will be given by what EV this is the potential between these two and you may say this is the voltage difference V distance is D okay so EV will be equal to 1 by 2 mv square okay so this is small v so now let us substitute and get the value of E by m so directly if you just bring this m side E by m will be equals to 1 by 2 okay so in numerator there is v square in denominator this capital V will come okay so if you substitute the value of v square then what would happen is 1 by 2 v and this is E by b square अब यो फेरि इलेक्ट्रिक फिल्ड को भ्यालु हामीलाई थाहा छ क्लास 11 मा हामीले पढेका छौं पोटेन्शियल ग्रेडियन्ट इज इलेक्ट्रिक फिल्ड सो दिस इज v by d ओके माइनस पनि भन्छौं नेगेटिभ ग्रेडियन्ट अफ पोटेन्शियल इज इलेक्ट्रिक फिल्ड सो हामीले यसरी लेखेको थियौं क्लास 9 मा सरी क्लास 11 मा सो हामी यस्तो गर्छौं so 1 by 2v okay E means capital V by d okay distance is in place of x there is d okay so b is here so you can just write the square of this and 1 by b square so this is going to be your E by m okay I hope you are well known about the theory of this okay let me continue okay write the value of specific charge okay the magnitude of specific charge for the electron is E by m of electron is 1.7589 यो एकदम याद गरिराख्नु पर्छ 7589 into 10 power positive okay 10 power positive electron sorry positive 11 coulomb per kg okay so mass of the electron 10 power minus 31 हुन्छ electronic charge 10 power minus 19 हुन्छ त्यसैले यो मास को भ्यालु नेगेटिभ माथि जाँदा पोजिटिभ हुने भएर यो अल टुगेदर टोटल भ्यालु चाहिँ पोजिटिभ नै आउँछ ओके सो लेट अस मूव अन टु अनदर क्वेशन that is OR question of the same let me erase this all to continue OR question so let us look at in OR question first describe the quantum nature of radiation so Einstein was the first person who could correctly figure out the quantum nature of light quantum nature of light means the light or the radiation consists of packet of energy called photon okay packet of energy called photon so this photon description of light is called quantum nature of radiation okay let's look at B number you can easily write the definition for that one which phenomenon justifies the particle nature of radiation the same one okay the quantum nature or the phenomenon of photoelectric effect so कसरी यसलाई बुझ्ने त भन्दा हामीलाई थाहा छ क्वान्टम नेचरले रेडिएसन सँग प्याकेट अफ एनर्जी हुन्छ जब यो एनर्जी यहाँ भएको इलेक्ट्रोनलाई इम्पार्ट गरिदिन्छ यो एनर्जी यो रिजनमा इम्पार्ट गरिदिन्छ भने यो इलेक्ट्रोन अब एक्साइटेड स्टेटमा जान्छ र यो कुनै अर्को एनर्जी लेभलमा गएर बस्छ एक्ज्याक्टली यो कुनै अब्जेक्टले अर्को अब्जेक्टलाई मोमेन्टम ट्रान्सफर गरे जस्तो देखिन्छ है। कुनै पार्टिकल एउटा ठुलो ढुङ्गाले सानो ढुङ्गालाई हिर्काउँदा वा सानो ढुङ्गाले ठुलो ढुङ्गालाई हिर्काउँदा जसरी मोमेन्टम एकले अर्कोलाई इम्पार्ट गर्छ, एक्ज्याक्टली त्यसरी नै यहाँ पनि एनर्जी एन्ड मोमेन्टम विल बी इम्पार्टेड। फर द्याट रिजन दिस इज कल्ड पार्टिकल नेचर अफ लाइट। ओके, यो पार्टिकल जस्तो बिहेभ गर्छ यो हाम्रो फोटोनले। ओके, so this is what the idea of which phenomenon, that is photoelectric effect, is the one that justifies the particle nature of radiation. Okay, question number C हेरौं। C number मा हामीलाई के दिएको छ भने how Milken determine the Planck's constant. Okay, so from Einstein photoelectric effect, what we know, so you just draw a diagram because it is asked for 3 marks, and what you do in mathematics simply is from Einstein photoelectric effect we know that energy carried by this photon will be utilized to knock out the electron and give kinetic energy for the particle. Okay, so this energy is E equals to h nu. Okay, h nu, and this is work function. Work function को लागि एउटा पर्टिकुलर फ्रिक्वेन्सी चाहिन्छ, त्यो भयो। त्यो बचेको काइनेटिक एनर्जी हामी कति लेख्न पाउँछौं 1/2 mv²। ओके, सो अब यो काइनेटिक एनर्जीलाई मिलाएर लेख्ने हो भने 1/2 mv² इक्वल्स टु h nu minus h nu naught हुन्छ। ओके, यो काइनेटिक एनर्जी कसले दिन्छ त भन्दा पोटेन्शियल दैट वी हैव प्रोवाइडेड। ओके, इलेक्ट्रोन निक्लेर हिँड्ने हो, त्यसैले इलेक्ट्रोन सँग भएको पोटेन्शियल एनर्जी will be utilized in kinetic energy. That's why h nu minus h nu naught. So if we just look at this V, then it is going to be equal to h by E nu minus h by E nu naught. Okay, this all is constant. You h पनि constant, E पनि constant, nu पनि constant. So your equation simply represent garcha y equals to mx plus c, and this part is the intercept, negative intercept will be there. Therefore, comparing with y equal to mx plus c, m equals to h by E. So if you wish to calculate the value of Planck constant, then you can simply multiply slope with electronic value. Okay, so this gives us the value of Planck constant. So if you just plot the frequency and potential, then you will get a curve like this one, and this is going to be your nu naught, that is threshold frequency. And if you just draw here triangle structure, this is going to be theta, and this theta is tan theta equals to delta V by delta F. Okay, so from here we can easily calculate. Okay, if somebody wish to get this value in terms of this one, then H will be equal to E times delta V by delta F. This also gives the value of Planck's constant. Okay, so this is what the solution for our question. Now let us move on to another, that is question number 7. This is a diagrammatic question, graphical question, and here what the information given, let us look at. This is cesium 134. Okay, A is 134 and oh sorry, this is, yeah, this is 134 and Z is 55. Okay, use the graph to determine the half-life. Okay, half-life भनेको त्यो टाइम हो जुन बेला total number of nuclei will be reduced to half. अब यो 400 बाट स्टार्ट छ भने 200 मा पुग्दा कति टाइम लाग्छ? Let us look at from the graph. यो ग्राफ बाट हेर्ने हो भने this is 2, this is 4, this is 1 2 3 4 5 lines are there. Okay, so this is 2.4, this is 2.8, this is 3.2, 3.6. So from this diagram, here 200 is intersected in this place. Okay, let's use another pen. So this 200 is intersected in here. Okay, so this is your 2.4 years. So from graph T half equals to 2.4 years. Okay, this for 1 marks. Find the decay constant of the radioactive nuclei. Okay, so simple. From this information, we know what we know is decay constant equals to 0.693 divided by half-life. So this comes in for here. Okay, so third number, what would be the remaining activity after 12 years? Okay, so हामीलाई activity दिएको छ becquerel मा, that is disintegration per second, 1 disintegration per second. So सुरुको number र activity को relation similar हुन्छ. I already have discussed. N equals to n naught e to power minus lambda t or r equals to r naught e to power minus lambda t दुईटै equally workable छ किनभने rate is directly proportional to n. त्यो भएको कारणले दुईटै फर्मुला युज गर्छौं. दुईटै फर्मुला इक्वली युज गर्न सकिन्छ. हामीलाई जुन बेला रेट दिन्छ रेटको फर्मुला युज गर्छौं, नम्बर दिएको बेला नम्बरको युज गर्छौं. हामीलाई यो पर्टिकुलर केसमा रेट दिएको छ. सो r naught equal to 400 becquerel. ओके, bq. सो हामीलाई r को भ्यालु पत्ता लगाउनु पर्ने कति टाइम पछाडी 12 years. Okay, how many years are there? Altogether 12 years. So half life 2.4 छ. कतिवटा half life पास भयो भन्ने फर्मुलाबाट पनि निकाल्न सकिन्छ. Otherwise we have a general relation, this one, t half equals to 2.4 years, and you already have calculated lambda. This is per year. So using, so since r equals to r naught e to power minus lambda t, you can simply utilize this. In here t is 12 years. You have not to change anything, but I believe you should do, because this is given in becquerel, that is disintegration per second. यो 400 disintegration per second मा छ भने यो years मा छ. त्यसैले हामीले यसलाई मिलाउनु पर्छ है, यसलाई मिलाउनु पर्छ. अर्को कुनै मेथड छ यो नम्बर अफ हाफ लाइफ वालाबाट, यो अल्टरनेटिभ मेथड हो. यो r by r naught equals to 1/2 को पावर नम्बर अफ हाफ लाइफ हुन्छ है. अब नम्बर अफ हाफ लाइफ चाहिँ कतिवटा छ भनेर निकाल्ने त. लेट मी जस्ट डु इन हियर. सो नम्बर अफ हाफ लाइफ चाहिँ भनेको टोटल टाइम बाइ एउटा हाफ लाइफ को टाइम, यसलाई नम्बर अफ हाफ लाइफ भन्छ. टोटल टाइम कति छ 12 इयर्स, एउटा हाफ लाइफ को 2.4 इयर्स. यस्तो गर्नु पर्यो भने यो डिसइन्टिग्रेसन पर सेकेन्ड छ, या सेकेन्ड छ, या इयर छ, यो चेन्ज गर्नुपर्छ यो प्रोसेसले गर्दा. तर इफ यु जस्ट डु विथ दिस प्रोसेस, यु डोन्ट हैव टु डु एनीथिङ. यो जुन रेटमा जुन युनिटमा हुन्छ यो पनि त्यही युनिटमा हुन्छ है. सो दिस इज समथिङ यु क्यान इजिली क्याल्कुलेट. ओके, सो यहाँनिर के हुने भयो, r इक्वल्स टु r naught 1/2 को पावर 12/2.4. This is so simple method. This is in power. Okay, यो गर्न म चाहिँ यो गर्नको लागि प्रिफर गर्छु है. एनीवे दिस इज फर 2 मार्क्स. त्यसैले यो गर्न सकिन्छ. सुरुमा यो सबै इन्फर्मेसन लेख्ने, नम्बर अफ हाफ लाइफ निकाल्ने र यो फर्मुला युज गरिदिने भने इट वुड बी quite easier. Okay, let me erase this all and I will move on to another question, the last question of group B. So let us look at question number 8. The energy level of the hypothetical atom is given in the adjacent figure. So 0 electron volt, 1 electron volt and 3 electron volt. Reality ma ta 0 huँदैन ground state. At hydrogen ko pani -13.6 electron volt jati huncha, yo hypothetical. What are the frequencies of spectral lines that atom can emit when it is excited? Okay, so हामीलाई थाहा छ possible wavelengths are, so हाम्रो के हुन सक्छ त भन्दा frequency spectral line the atom can emit. So third state बाट 3 electron बाट ground मा गयो. Okay, so R E, let's say 0 1 2, this is this one, let's say this is uh, 3. Okay, 3 level, this is 1 level, and this is 0 level. So E3 level minus E0 equals to H nu. So E3 minus E0 will be equal to Hc by lambda. Let's say this is lambda 1. So यहाँबाट हामी easily निकाल्न सक्छौं. यो 3 minus 0 means this is 3 electron volt. Okay, 3 electron volt equals to Hc by lambda 1. So electron volt हामी easily 3 into 1.6 into 10 to the power minus 19 joule. Okay, so H को value substitute गर्ने अनि C को value पनि substitute गर्ने, lambda को value निकाल्ने. So from here you can easily get lambda 1, so some meter. Exactly in the same method, same way you can calculate for second. So for second frequency, so अर्को possibility के हुन सक्छ त? So third बाट ground state मा, second बाट ground state मा पनि जान सक्छ. Okay, so for second frequency it may go from E3 to E0, or sorry, E3 to E2. E2 मा जान सक्छ. That is again going to be H nu. Okay, so this is 3 minus 1 electron volt. Electron volt equals to Hc by lambda 2. अब आफै substitute गरेर निकाल्न सकिहाल्छौ. Lambda 2 equal to, this is possible. Finally, third frequency. Okay, third frequency and wavelength. यो कसरी निकाल्ने त? So third बाट ground मा गयो, third बाट second मा गयो. हेरौं, यो ट्रान्जिसन हामीले हेर्यौं, फेरि थर्ड बाट सेकेन्ड मा पनि हेर्यौं, फेरि ट्रान्जिसन त यहाँबाट यहाँ पनि हुन सक्छ नि, second to 0. Okay, so therefore E minus, actually this is E2 minus, oh sorry, this is E1 we have mentioned, not 2, this is E1 volt wala, electron volt wala, E1 minus E0 equals to H nu. Okay, so this is 1 minus 0 equal to Hc by lambda 3. So on simplification, we can easily get the value of lambda 3. Okay, so this is so important question. हामीले सबै possible wavelength र frequency लाई हेर्यौं. Okay, अब अर्को question छ B number मा, what wavelength can the atom absorb if it is in ground level? Ground level बाट यो एउटा photon absorb गर्न सक्छ र अर्को यो photon पनि absorb गर्न सक्छ. त्यसैले हाम्रो यो previous example मा लिएको, so ground state बाट यो जुन हामीले frequency निकालेको छ, यो wavelength भएको photon और यो frequency भएको photon, यसको frequency पनि हामी निकाल्न सक्छौं. यो frequency भएको photon, त्यसैगरी ground state वाला हेर्नुभयो, यो ground state बाट first excited state मा जान सक्छ, ground state बाट second excited state मा जान सक्छ. That's why, okay, so यो ground बाट third वाला भयो, this one, यो ground बाट यहाँ गयो. So यो केस मा आउने जुन frequency हुन्थ्यो, यो पनि absorb गर्न सक्ने है. यो रेड कलरले लेखेको चाहिँ absorb गर्ने possible frequency हरु हो. किनभने right amount को frequency नआउन्जली, right amount को energy नपाउन्जली कुनै पनि इलेक्ट्रोनले एनर्जी रिसिभ गर्दैन, किनभने यो क्वान्टाइज्ड हुन्छ. यो डिस्क्रिट हुने भएको जुनसुकै एनर्जी क्यारी गर्न सक्थ्यो, क्वान्टाइज्ड हुने भएकोले पर्टिकुलर फ्रिक्वेन्सी नआउन्जली समयले एब्जर्ब गर्दैन, राइट. सो ग्राउन्ड स्टेटबाट एक्साइटेड स्टेटमा जान आइदर यो फ्रिक्वेन्सीले रिसिभ गर्न सक्छ और यो फ्रिक्वेन्सी रिसिभ गर्न सक्छ. यु क्यान जस्ट राइट इन ल्याङ्ग्वेज फर क्वेसन नम्बर बी. ओके, यो म्याथमेटिक्स किन सेम म्याथमेटिक्स गरिराख्ने भनेर मैले यहाँ गरिन. ओके, सो दिस इज the end of the group B. So we will be meeting again in group C. Till then, thank you all.